Hello and welcome to everyone. Thank you guys for joining us for this webinar. This is the CAM Solutions Gibbs Cam Probing webinar. And this is Brandon Black. Most of you guys know me. I recognize the names that are in the list. And I'm going to be joined today by Patrick Mooney. He's going to go over all of the probing details here for us. And if you have any kind of questions at all as we go along, feel free to put them in chat. And we're going to be taking some time to review a couple questions. And then the rest of them we'll try to get to you guys offline. So if any of you guys didn't know, probing has been added to GibbsCAM 14 now, and it's all internal. And that is what we're going to be reviewing today. So without further delay, I'll hand it over to Patrick, and I'll join you guys again at the end for the question session. All yours, Patrick.
Thank you. Thank you so much, Brandon. And thank you for joining us. Today, we are going to talk about Gibbs Cam Probing, how it works, what you need to make it work. And more importantly, today, our focus is going to be, why should we probe within our CNC program? But first, let's look at the first slide that we have here in our PowerPoint. And this webinar will highlight datum setting just prior to machining, critical part feature analysis, updating wear compensation values and work offsets on the fly during the cycle, and creating an inspection report after the completion of machining. And what we're trying to impress upon you today is that this is going to be a conversation about things that we do with probing, not so much how, because the how is very simple, but the why. The tagline of this webinar is, your probe is not just an edge finder anymore. Most people have a probe lurking in their CNC machine somewhere in the tool changer, and they bring it out every once in a while to find the corner or to find the bore of a part. But if you could do that automatically inside of GibbsCAM and be able to control your program with the door closed and have the probe automatically update your wear comp offsets and automatically set your datums, you will find a tremendous benefit. We're going to talk about those benefits. And the focus is, why do we probe? We probe to achieve more input with your GibbsCAM, CNC machines, and Renishaw probes. What you need to incorporate GibbsCAM probing is, first, you have to have a probe in your CNC machine. And we're talking about the part probe. You also have to have the software that comes with the probe from Renishaw, and it's called Inspection Plus, and it's resident in your machine. GibbsCAM interfaces directly with Renishaw Inspection Plus to output the probing code inside of your cutting program. Next, we want to increase automation and reduce human intervention. That helps to introduce process stability and repeatability. We reduce scrap, rework, and concessions to your customers. You can shorten manufacturing lead times, and you can also increase process capability and traceability through critical feature reporting. And the focus now, streamlining your CNC process by adding automation through probing. At the end of this webinar, we will have a Q&A session. Let's go to the first part file and see what we have. Here we have a test part that we use for probing, and this is called the master probing test part. It has a number of different features, and here we are talking about setting the datum of the part. If you're not aware of this, setting the datum of the part is part of the step application system of CNC management. And yes, when you purchase this software option from GibbsCAM, you will purchase the Gibbs Cam Probing option, and you will also purchase a post processor upgrade for each post that machine has a probe in it. And you will also get a tremendous amount of documentation that will help you quickly understand and quickly implement productive process patterns into your CNC processes. Let's go back and have a look at the file first, and then we'll come back and look at productive process patterns. Here we have a part that needs to be datumed before we run it. Let's look at a Gibbs Cam probing process. The process looks just like any other process, except here instead of the tool, you see a probe. We get to set the feed rate that it approaches the part. Once the probe is turned on and it is in protected mode, the probe will approach the part at 100 inches a minute feed rate. This cycle type is going to be a single surface, and we are going to set work fixture number 1. We have other cycle types that we'll talk about in just a few minutes. And here we can either set work fixture, or we can measure that surface and output that measurement to a variable register in your machine. You have your work fixture index. We're going to set it to G54. It's going to be a 2-touch cycle. The standard clearance for a Renishaw probe is 10 millimeters away from your surface before you start probing. And in this case, since we want to set this as -1, because that is the top of that surface, you can see here if I click on it and look at my show position indicator here in the corner, you can see that that surface is -1. And the probe will contact this Z-axis surface from the positive side. Let's have a look at the probing cycle, and you can see here we selected a point. That's all we need, is a point anywhere on this surface to probe. Let's take a look at this in machine simulation. Here we have a new DMU 75 with a new round enclosure. And let's zoom in on the part, and you can already see where the probe hits are going to take place. We're going to probe the top of that circle, and we're going to probe these 2 corners and set these to G54, X, Y, Z, 0. Let's have a look at the corner probing process. And yes, it says corners, lower left-hand corner. What's the distance to step over from each edge? 1 inch. What's the Z distance for probing from the top of the part? -1.25. It is an outside corner, and we're going to set the work fixture offset of G54. Let's look at that again, and then we're going to have a quick look at the code. Rewind and play. You get to see the hits during the probing process, which means that if you have collision checking turned on, and if you have collision checking settings, stock flash, log to display, you may get a collision. In this case, I think they have fixed it and we don't get a collision anymore, but there we have probed the corner of the part. And let's have a look at the posted code. The posted code should be familiar to you if you are familiar with Renishaw Inspection Plus. And the code starts with the tool change, position the probe over the first probing point, and bring it down to the master clearance plane. We turn the probe on. You're familiar with this code. We approach the part, and then we measure the part, and S1 outputs it to G54. S2 would be G55, S3, G56, and so on. So this measures the top surface. And then we pull back up to the clearance plane, and we measure those 2 corners, and then set that corner to G54. To do this in GibbsCAM is very simple. We'll start from the beginning so you can see what it looks like. and it works just like any other Gibbs Cam process. First, let's look at the support that we have for probing tools. As you can see here, we have a probing tool. We support ball tools, disc tools, cylinder tools, 2D and 3D form tools. This probe that we have described here is the standard 6mm by 50mm Renishaw probe that comes with probably 99% of all machine tools that are shipped here in the United States. You either have a 50mm or 100mm. And we can zoom in and, of course, look at that probe and the stem and the stylus. We bring the probe into the process list, and from our process menu, we select shapes. Single surface, set work fixture 1. Master clearance, we'll set this to 2 inches. Work fixture index. Clearance, we want to be 0.4 away from that, and probe depth is going to be 0. When it meets this point, whatever that point is, GibbsCAM and Inspection Plus will set that surface to 0. So here we have created a process and an operation that will happen automatically every time you shut the door. What this does for you is it reduces your setup time by as much as 90%, and it reduces setup errors almost to 0. Because now we load the part into the machine, we close the door, and we push the go button. We call this a green button process. It datums the part and it starts to cut automatically. Now, what we are eliminating is the lag time and the process noise that might happen. Somebody's inside the machine with an edge finder. Somebody comes up and interrupts them, asks them a question. Hey, where's this tool? None of that happens because the probe is focused on its job. And when you push that green button, everything happens sequentially, and your part program becomes consistent from start to end every time, giving you more consistent results on your process. Let's go back to productive process patterns and discover the types of activities that we can expect to perform inside of our machine with our probe and with GibbsCAM. What are productive process patterns? These are preventative process foundation patterns. Predictive process setting patterns. Right here, just before cutting, we use the probe to find the part, and it does it every single time. And then we have active controls applied during metal cutting. We can measure a surface and then adjust a wear comp. And then when we are done, we can measure the part and output a measurement report inside of your machine or into your machine's variable register so that you can see what dimensions came out. This allows you to manage your CNC process from the foundation out. Your parts flow from bottom to top. Instead of you taking the completed part out of the machine, finding out what's wrong with it and working backwards, we help you to work in a forwards flow, and that's why we call this a productive process pattern. This is also step application protocol number 10. The step application protocols come with the software, and you get to see all of the activities that you can engage with your probe inside of the program. Here, let's look at process setting, part identification, part presence check, job setup, AP203. There we are right there with setting the datum. If it doesn't find a part and it says that the part is not there, it's simply going to stop and say not found. That would prompt the operator to look in the machine because the red light's going to come on, put a part in, restart the program, and the job setup happens automatically. This is step application protocol AP203, and this is what we just accomplished here with our Gibbs Cam probing. Let's go to the next file, file number 2. Let's have a quick look and see what we have in there. That was a 5-axis vertical, but we just did a simple 3-axis probe on it. Here we have a part on a tombstone in a 4-axis horizontal. And on this tombstone, we have a part that has 3 coordinate systems: a front coordinate system, a left coordinate system, and a right coordinate system. We have prepared this for you, and we're going to show you the dinosaur first, like they did in Jurassic Park. You get to see the dinosaur, and then we show you how we made it. We probe the corner of the part. We probe the front of the part. That was G54. This is G55. And then we probe the other side of the part, G56. This part is now ready for production. If these were parts that were pre-machined in a previous operation, Op 10, and you loaded them into the vise here for Op 20, and you don't have room for a part stop, the operator simply puts the part in the vise, the probe finds it, locates it, and sets the datums automatically, reducing your setup time by as much as 90%. So what does an operation look like on a 4-axis machine? It looks exactly the same as it does on a 3-axis machine, except we have different coordinate systems. We have XY front, XY right, XY rear, and XY left. On this part, we use front, right, and left. This one's not too exciting because it's on the front edge of the part. We can double click and move through and move through and move through. And let's look at Op 4. Op 4 is simply done on XY right, just like we do on any other machining process. The probe works with coordinate systems exactly like your tool does. And we set this work fixture here. I did an X-axis set single surface, probe depth minus 250, and it sets this surface at, in this case, an H value or an X value of 0. Again, we work our way around the part. We've got the Y, we've got the Z, and now we go to the left side of the part. Here, 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 and then we go to machining. So let's have a look at that one more time, and then we're going to show you what it looks like inside of Tombstone Management System, because the Gibbs Cam Probing application is compatible with TMS. Let's watch this happen one more time from the top view. G54, G55, and G56. Very quickly, we're going to skip to the next part file because we already have TMS set up for this, and we're going to actually look at some of the code as it comes out of the machine. Here we have the part set up. Let's go to Machine Sim. And now all of this work that would normally be done by an operator is now done by the probe, while the operator is busy doing other things, cleaning parts, preparing parts for CMM inspection, or preparing parts for post-processing, such as surface finish prep, heat treating, or other types of coatings, or even paint. This happens automatically every time you close the door. Your decisions are carried out inside of the machine, even when you're home, asleep, and you have operators working in your plant at night. An unskilled operator can run this machine because the probe is now doing what you told it to do. The problems that you encounter without using the probe are inconsistency due to variations in your program cycle due to interruptions. Anytime that you stop that program to either measure the part or make an offset, you have created variations that can affect the quality of your part. So we've identified the problem. Let's talk about the solution. The solution is add probing cycles and integrate them with your machining operations to create a green button process with consistency and stability. Let's go back to file number 2, and let's have a quick look at the code that came out for this 3-axis. This is a 4-axis machine, and we have 3 coordinate systems. We'll go directly to the post button, and let's grab our sample post. We'll use this FANUC demo post right here, and here we are. As you can see, op 1, 2, 3, and 4, the work coordinate systems are here. The probing is done automatically, and this probing code, of course, you can generate by hand, and that's probably what you've done so far, but it's tedious and it requires meticulous checking before you cut it loose in the machine. Here, we can program the probe offline in a virtual environment with no danger to your machine or your process or your probes. We know that we went to operation number 4, and we will find that we've got some rotation going on here, B90, and we are now probing in coordinate system G55. The probing code's very clean, very easy to understand, and very easy to manage inside of your machine. Let's go to the next part file and have a look at what other types of activities can we do. This is going to be file number 4, cutter parameter update. Wouldn't it be nice if you could have Gibbs Cam and Renishaw Inspection Plus automatically update the wear comp on your tools? Let's go look at application number. Let's go look at right here, job setup, AP301, cutter parameter update. Each of these step application protocols comes with a PDF that tells you what the problem is, tells you what the solution is, and how to implement that solution, what the benefits are, and a case study from a real-time customer. It even shows you what the code would look like in Inspection Plus in your machine. Cutter parameter update. We want Gibbs Cam to update the wear comp on your part. So here we are. We have this bore. This bore is 2 inches in diameter, and we have roughed it out, and we have taken a semi-finished pass here in op 1. In op 1, we have a semi-finished pass, and we have left 5 thousandths inside of the bore on either side of the bore. Now with the probe, we put the tool away, and that's our finished tool. We did a semi-finished pass. With the probe, we come in and measure that bore. If it's undersized, everything's okay, we continue. If it's oversized, we issue an alarm saying this part is scrap. It's no longer viable to be machined on. We might have another 2 or 3 hours of machining left on this part, and we want the probe to tell us if it's good or if it's not. But here we selected a measurement cycle. We didn't set the work fixture. We are going to measure this bore. And once we measure this bore, what we're going to do is we're going to update the work fixture offset, I beg your pardon, the tool diameter wear comp value, and then we're going to bring the tool back in. It's been adjusted. Now, how was that tool wear comp adjusted? When this probe cycle comes in to measure that bore, since we have it set to measurement, it replaces the S1 at the end of the 9814 line. It replaces it with a T2, which automatically takes the error. We left an error in there of 5 thousandths. So it knows it's looking for 1.995. It takes the difference between 1.995 and actual, and it automatically puts it in the wear comp table on your machine. Let's have a look at the code, see how it comes out. FANUC 30i probe demo. Let's go look at op 2. Let's go quickly to op 2. And here we are on the probing right here. In the 9814, we have a tolerance in there. And at the end of this line, you will see a T, beg your pardon, a T2. And the T2 will automatically output that value to the wear comp table. And then in the next op, we come in and do our finish pass. We have 0 stock. Now, what this has the net effect of doing is automatic cutter parameter update, and it will help you get your parts as close to your machine capability as possible. What is your machine capability? And this is a big question, because at the beginning of the day, when you come in the shop, the first question should be in your mind is, are my machines accurate enough to machine my parts without making scrap? And you can answer that question with the Renishaw probe. The Renishaw probe will help you get the machine into that machine's capability. If you've had a Renishaw ball bar test run on your machine and you were given a capability certificate of 7/10,000ths of an inch, which means that your machine has the ability to hold 7/10 on a 2-inch diameter bore, we can help you stay at that 7/10 or slightly inside of the 7/10, maybe like 6/10. And the reason that you can do that is because of the consistency of the cycle from part to part to part. And the probe even takes in consideration the fact that your tool might be wearing down, and it updates the wear comp. So here we did cutter parameter update, and that was AP301. Let's go look at another part, part number 5. And let's open part number 5. We just finished part number 4. Let's look at part number 5. And at the end of the cycle, we want to measure the part, and we want to output the measurement reports where we can get to it and assemble it into some type of a report for traceability. I'll select the whole part, and we'll go back into Machine Sim, and there's our pretty DMU 75. And let's look at a couple of the features that we're going to measure on this part. That critical bore in the middle, and did you see that? What we have here is we have support for a disc probe, and that disc probe did go down inside of here and measure that critical surface inside of that slot. And each one of those was output to a register in your machine because we said, just measure it and output the measurements inside of your machine. Now the question is, where does that data go in my machine? How do you know where the data goes? You have a book that came with your Renishaw inspection probe. And in this, in section 4-2, you have variable outputs. And if we did a Mohr cycle, which is G65P9814, it's going to output the size of that bore that it just measured. It's going to output it to your macro variable 188 in your machine. And your operator can simply press, if he's on a FANUC, he'll press position forward macro, and he'll be able to look at macro 188 and see the size of that bore. There are other ways that we can manipulate the data with applets. And these applets we will have on our website that you can download that will take that data from variable 188, and we'll make that 188 right here, and it will output that into an actual text file inside of your machine using the popen and dprint commands. This works on Siemens machines. It works on FANUC, Mitsubishi, and the other one was Okuma. All 4 of those controls had the ability to use an applet similar to this one to create an actual inspection report. And if you're a whiz with Microsoft Excel, you can import this, as you can see, comma separated value data into your Microsoft Excel report and see the nominal diameter, the actual measured, what the deviation was, lower and upper tolerance, and is it intolerance, yes or no? And this is an applet that will be available to you later. Here we have, let's go back and let's look at this cycle, and maybe we should slow it down just a little bit. Let's select all the components before we go into Machine Sim. Let's get the throttle off the firewall a little bit, and let's press the button and watch it again. We did the bore. We did this little pocket right here. It's a rectangular pocket. And we did the groove. Let's look at the types of probing features that we can work on. We have single surface, rectangular pocket, circular pocket, rectangular boss, and circular boss, as well as going back and we look at the corner cycles that we have for corners. Outside corner or inside corner or single surface from corner. And wait just a minute, did you see another button lurking over there? The basic probing. What is this all about? So you may have already created at your own expense a number of very high level macros for probing that you want to continue to use. And you can simply paste that code here, whatever that probing code is, G65P9810, Z0.0, F50.0. If you have macros like this, you can paste them right here into this process and integrate it directly into your program. And there is a warning here at the bottom that says, warning, the raw G code that you add here to a basic probing statement will not be validated or simulated by GibbsCAM. But if we output this post information that we have here, you'll see that the deep print information for your inspection report automatically appends each new value because your machine can only hold one value at a time. It can only hold one bore diameter at a time. So you need to be able to capture that, and we'll be able to help you with that with your tech support and your training on your Gibbs Cam probing. It is now 2:31 and we're going to start to wrap up, but what we want to cover is the summary of what we've talked about. Your expectations are in probing in that we will increase part quality by letting the probe interact with your program to create more accurate parts and reduce scrap. This works on small as well as large batch part processing. The work within your machine's accuracy capability to tighten output tolerances. We want you to understand that the probe is one of the most accurate measuring tools in your shop. And with Gibbs Cam probing, you can turn it from just an edge finder into a very accurate measuring tool that nobody has to climb up in the machine to use. If it can reach the part and measure it, it can give you the results. And your standard probe has 40 millionths accuracy. That's the OMP 40 or the OMP 60. Now, if you had elected to buy an OMP 400 or an OMP 600 Renishaw probe, the accuracy of that probe is 10 millionths of an inch. So the probe itself, its accuracy is not in question. And the summary of today's webinar is the profit impacts of in-process probing are, and this is what you can expect. The part and tool setting, reduce part and tool setting times by up to 90%. Probing is now automated and is more repeatable than manual methods. A more reliable setting process means less downtime once production starts. When tools are replaced, resetting will also be faster and less error prone. With less process noise to deal with, you are free to stop firefighting your CNC process and start to make lasting improvements in your shop. All this leaves you with better quality parts and more time to make them. Let's go back to our presentation here, and we're going to let Brandon step in, and he's going to run the Q&A session, see what type of questions that we have.
Thank you so much, Patrick. I'd like to thank you on behalf of all of us for that detailed presentation. A lot of information there. And there is a question right off the bat. Are if and statements allowed?
Yes, if and statements are allowed. You can use the all of the macro programming, and we do teach those macro programs. I am the instructor for Fanuc macro, Akuma macro, and Siemens macro. But yes, all of those are supported inside of the basic probing, and even some of the code that you will see when it comes out for cutter parameter update and upper and lower alarming. You'll see some of those macro statements in the Gibbs Cam code.
Very nice. And feel free to, as we're answering questions, feel free to use the chat if you want to put one in. I actually got one over text, and I'm sure this one will come up a lot. And I don't mind handling this one. It's if it's a paid option, which it is. So if you need a quote at all, there's a probing module, as well as you'll need a post upgrade. So if you need a quote or have any questions like that, or about any that come up, feel free to contact us, and we'll point you in the right direction, get you settled. That also brings up in my mind, since it's an internal module, there's a lot of benefits from that. One would be that, the NLO, you can have it on your network license, no problem. You can share it with anyone that's around. There's also the maintenance and support. So you're not having to go to anyone else for any kind of support. So it's totally Gibbs Cam related. You would still come to us for any kind of tech support, and it would go, or any training that you require, and we would get you settled with that as well. Now I see one that's jumped up here. If the bore is too small, it will adjust the offset and bring back the tool to recut. And I know that you had a example of that happening where it kind of cut and checked and then cut again. But I know there's a GoTo op as well that will be supported, that will go back as well and run the same operation. That is correct. Is that right?
Yes, there are a number of ways to accomplish what we call dynamic remachining, and it's called cut, measure, cut technology. And there are a number of ways to achieve that, and Gibbs Cam supports those.
Very nice. Now this one is one, can we add probing option to Gibbs Cam version 12, or do we need to upgrade to 14? And that is a requirement. You have to have Gibbs Cam 14, but going forward after that, the probing option will be available. So it's not a backwards compatible thing, I suppose. But buying a new module, you would be on maintenance and would be entitled to that upgrade as well. Now, I wasn't sure about this. I don't have as much experience on this, but what about probing a web?
Yes, the Mohr Cycle does a web as well. And the Mohr Cycle and the rectangular pocket cycle both support bosses, and they support webs. That's in the 9816 and 9814 Renishaw cycles. They do support those types of operations.
Very nice. And I expect them to keep on flushing this module out as well. It's the first rendition, so we'll have to see what's coming up as well.
Yes, you are correct. And there are plans to add new functionality to Gibbs Cam Probing. This again is the first iteration of Gibbs Cam Probing, and it covers basically datum setting, critical feature reporting, and with a very slight modification right now, your post will output. It will do cutter parameter update, and you can do dynamic remachining with the GoTo statement. So right there off the bat, we have 4 of those application protocols that are covered. Another thing that you can do is if you have a long tool cycle or a long machining cycle, and machining, the growth of the machine is a problem, either the spindle's growing or one of the other axes is growing, you can reset the datum at any time you want in the middle of the program. You could break a tool path, use the toolpath splitter and break a tool path in 2 and reset the Z-axis in the middle of that tool path, because you know that in this long tool cycle that the spindle is going to grow by, let's say, 1,000, 1,500, and that's unacceptable. In the middle or in quarters or in thirds, whatever you would like to do with your toolpath splitter, you'll be able to reset the Z-axis as it grows to maintain your accuracy.
Just sounds like a win-win. Yeah, a lot of good features that myself, not so used to the probing yet, definitely impressed. And we did have a question on what is a web, and it sounds like it was already answered that it is a wall measured on both sides. So I suppose you're going for the thickness there. Now, does it support Heidenhain? And I also got a question, what if it supports anything other than Renishaw probes?
No, it does not support anything but Renishaw probes, because this product is based on the Renishaw Inspection Plus software that is already in your machine. Now, if you do have another probe that is using Renishaw Inspection Plus software, like you might have a Bloom or a Marpos, but if it's using Renishaw software, yes, we do support it.
Very nice. And the Heidenhain.
And it's not us that supports it, it's the Inspection Plus that supports it.
Fair enough. And on the control side, have you seen any Heidenhain or Siemens controls supported?
I haven't seen a Heidenhain yet, but what I do have is Haas, Fanuc, Siemens, and Okuma. I have posts for all 4 of those right now. I've seen those.
And I wouldn't be surprised if that isn't expanded in the future. Yeah. Okay.
Yes, we'd be looking at Heidenhain, Brother. Now, Mitsubishi is simply a Fanuc clone. So Mitsubishi sort of falls in that category as well. And also Mazak falls in that category because it runs verbatim the same code that we run in a Fanuc or a Mitsubishi code. So if you have a Mazak and you're running it in EIA mode, it will be supported as well. I have a customer with 70 some spindles, and we have Inspection Plus running on most of those spindles in that shop.
That's quite a few spindles, I must say.
That's just in the one building. There's more than one building.
I gotta say, yeah, that sounds like an expensive endeavor, but very impressive. Now, this is a question that we might have to handle offline, but Productivity Plus is another, it's a plugin that's available. And I want to say, I shouldn't say anything, actually. This is probably more an office question that we can follow up, but just along the lines of quoting and cost and whether that entitles you to an upgrade or not is something that we can handle offline. Another one is the saving of processes, and it kind of goes down the same kind of path where it's not a plugin, it is inside Gibbs, so you can expect it to support all those kind of things that a normal Gibbs process would have, and one of them is saving the process. With the basic, you would have the code in there, as well as having the corners and the shapes being able to save.
And the other big thing is that it is NLO supported, network license option supported.
Yes. And I want to say that would mean, you know, you can share it on a network. Anyone that doesn't have a network license, that is a pool of licenses on a server that you can share. So with or without probing, if you find that you're fighting over a key or any licenses you've expanded, that is an option to have a pool of licenses that can be shared and people can check them out. And it gives out as many licenses as you own. So you would be able to get one probing license, let's say, and share it among as many clients as you need. And I agree, that's a great thing. That's a great plus right there.
NLO TMS. It's supported in Tombstone Management System because it is an integral part of GibbsCAM.
Now it is. It seems like they've really integrated this nicely. And I would have to say that we'll close her down now. I hope that everyone has enjoyed this. It's definitely been all positive on my side, Patrick. I really appreciate you, all of your wealth of knowledge of being in the trade so long and the probing side of things. And any kind of questions that you guys have at all, feel free to contact us. We'll be happy to answer any questions, and you can give us a call or an email at Cam Solutions. This is all our customers, but of course, your local reseller as well, if you do end up being a remote. So thank you, Patrick, and thank you everyone that joined us. I hope you all enjoyed.
Brandon, thank you so much. Thanks everybody for joining.